Hi, my name is Matthew Oreskovich, and for project 2, I got problem 8. So to start, here's the problem. And to start off, we have to find the partial derivatives. So for this, since it contains an x, we're finding f of x. So since this contains x, you find the derivative, and you would get 1/2 x squared. And then this also contains an x, so the derivative is 2x. And this contains an x as well. But x's derivative is just 1, so it basically cancels out, and it's just y down here. And this contains 0 x's, so it's basically a constant. And then going down to find f of y, it's constant because they don't contain any y's. This contains a y, and it basically turns into a 1 for its derivative, so it just comes down x down here. And then the derivative of negative 1/2 y squared is just negative y, so that's your f of y. And then to find all of your critical points, you have to pull down the f of x and the f of y, and then set it to 0. So right here you can see for my first equation, f of x, I set to 0, and then f of y set to 0. But right here, I already solved for f of y because it didn't take much work. I just added y to both sides, so x equals y. And then I brought it over to the other side. I solved, and then I plugged y in as well because x equals y. And so for my critical points, I got 0, 0, and then -6, -6. And then so to find the second partial derivatives, we have to take it up from here. And so your f of x, you get x plus 2, and then you get 1, 1, and then -1 by solving all those. And then to classify the critical points according to the determinant test, you have your formula right here. So f of x times f of y minus f of y of x squared. And then, so basically you just plug in what you pulled up here. And I then take those over here to find these. I start plugging in my critical points from up here. So I ended up getting -3 for this one. And since it is below 0, I got my saddle point. So I got a negative right here, saddle point. And then I did -6, -6. Plugged it all in, and then I got +4, which is greater than 0. So d is positive, f of x is positive, and it's a relative min. So there was no relative maxes, so I got none for that. Relative min is at -6, 6, and the saddle point is 0, 0. Thank you.